Right, let's just quickly revise cells. Okay, let's get started. Thank you. So let's just revise this. Who says that this here is a voltaic or galvanic cell? Hands up. Is this a voltaic or galvanic cell? Let's say, who says it's voltaic? Who says it's electrolytic? You say, Asia? Okay. Let's see if we... Okay, who can tell me what kind of cell I'm drawing now?
Voltaic.
Well done.
See, tell me.
Okay, who can give me another name for voltaic?
Galvanic. Galvanic.
Who knows a voltmeter or galvanometer is a meter? So this cell can move a meter. So we put either a voltmeter or we put some sort of meter here. Okay, now inside here are copper sulfate ions. Who can tell me what copper sulfate dissolves into what type of ion? What type of ions are in that solution?
Copper.
Lovely, but don't say copper. Copper 2 plus. Super. Thank you. So that's both of yours, Jade? Yes, sir. Okay, Jade. Done. You're number 5. Thank you, Tamika, both. Okay, Tamika. You're number 6. Well done. Okay, and what other ions are there? When you see copper sulfate, you see copper ions and sulfate ions. SO what? Do you know what the sulfate ion is? SO 4 2 minus. You've got to be able to see those ions.
So would the sulfate always be negative?
Always. Always, and I'm going to send you a table of ions. They're simple, just memorize them, guys, because you must be able, when you see copper sulfate, to immediately strip it down to copper sulfate. Now, which side is negative? Which side is positive?
The negative is a short positive.
Okay. Now, which ions are attracted to the positive?
The positive.
Which ions are attracted to
the sulfur. The sulfur ion.
the negative ions, right?
Yes.
Or anions.
Anion.
And the copper are attracted to the?
Negative.
There we go.
So copper for negative.
Well, I have to work it out myself. So let's just see what happens at the negative pole. It will, that's the answer. But let's see why. So when copper 2 plus gains 2 electrons, what does it form? You see, it's going to the negative to get something. It's attracted, but it gets something. It gets electrons.
Oh yeah,
So what does it form? Cu 2 plus 2 electrons form
copper.
just copper what? Metal.
Copper plus.
Metal. Again, guys, you must be able to see that that is the iron, that is the metal. Doesn't write solid on that redox table, but you must be able to see it. And then when the sulfate goes here, it will lose 2 electrons to the positive, and so here's our flow of electrons, which is negative positive, but now conventional the other way. Now, here's the kind of question they're going to ask you. The positive does this to the copper. So this is what occurs here. Here, the positive is stripping away. The positive is putting electrons away from the copper to form copper, goes to form Cu 2 plus 2 electrons. The exact opposite is occurring at this electrode. Now, who can explain why? Why is this copper dissolving, and why is it dissolving at that electrode? Matthew, would you like to give it a go?
Why is it dissolving?
Okay, let me try and talk you through it. Matthew, in the solution, which is a little bowl, have we got copper metal? Have we got copper ions? Have we got electrons? Do we have a reversible reaction possible? We have, because we've got everything there. Now, if I remove electrons, according to Le Chatelier, if I take them away on this side, the reaction is going to go in the direction to remove what I've just done. I've just taken away electrons, so it's going to go in that direction. Does that make sense to you, Matthew? So when it goes in that direction, because I keep removing electrons, it keeps forming copper ions. It's a sort of equilibrium situation. We can shift the equilibrium by taking away electrons or giving electrons. Aiden, would you be able to explain what I've just said?
Yes. Try.
Give it a go.
Down.
Now,
Um.
in the jar we have a what situation?
Equilibrium.
An equilibrium. The equilibrium is between the metal and its ions. If we remove electrons, which direction will it go?
Direction of the ion.
The direction to start creating more electrons, because we removed electrons. That's Le Chatelier. So if it goes from copper metal to copper, this is going to what?
To dissolve.
Dissolve. Now, when the metal dissolves, it's also called, it begins with an O. Any of the ladies?
Metallation.
Thank you. So this reaction is oxidation. Oxidation is occurring at the positive electrode. And what do we call the electrode at which oxidation occurs? We call it the anode. You see, Aiden's with us here. So this is the anode. Now, how do we remember it? We remember an ox. Anode, ox. And I think of oxidation as like rusting, it's falling apart. Now, what is occurring at this electrode where the copper gains electrons to form copper metal?
Reduction.
That is reduction, and this must be the anode or cathode?
Cathode. Who say cathode?
red cat. So that cat stands for cathode. So would you remember it? Reduction occurs at the cathode, red cat, and oxidation occurs at the anode and ox. Make sense? And which electrode in an electrolytic cell is positive? The anode. Now we know it's the exact opposite here. So if I can identify the anode, I know that it's going to undergo still oxidation, but it's going to be the negative electrode. Okay. So this is a separate drawing, by the way. Let me just try and make it look a bit more separate. Okay, so what should we put here? Let's put here zinc. And inside the solution is a zinc ion solution. And what type of solution do we put in here?
Copper sulfate.
A copper sulfate, a copper 2 ion solution. Okay, anything with copper in it. Now, do we know that one of these is going to be oxidized and one of these is going to be reduced?
Yes.
Do we know that?
Yes.
Right. Now, where do we go to find which one's oxidized and which is reduced?
Standard reduction table.
We go to our reduction table and we look for who on top?
Z. For Liam Neeson.
Lithium or lithium on top.
For Mr. Neeson.
And the top half reaction is always going to be the one that is giving electrons, because Liam's the most giving person. Then we go to we'll find Liam or zinc on top. And we'll find copper at the bottom. So if zinc is giving, it's going to do this. Zinc goes to form Zn 2 plus 2 electrons. Now those 2 electrons are going to go off there. And they're going to turn this electrode negative. Because zinc is giving off electrons. So do you see now, this is oxidation, but this is therefore the anode. But look at it, it's the negative electrode. Because zinc is dissolving and giving off electrons, turning it negative, the electrode. Tamika, does that make sense at all? Okay. Now, what is copper? For every giver, there has to be a getter. It's the law of the universe of electrons. Electrons can't sit in limbo. They've got to go somewhere. So if something's giving, something's getting. That's why we call it redox. Oxidation must occur with reduction. Reduction must occur with oxidation. Okay, so we know that here the reverse reaction is occurring. Copper 2 plus 2 electrons is going to form copper solid metal. So this electron, will it grow or shrink? It's going to grow. That's a growing reaction. This electrode, what's going to happen to the zinc? It's the shrinking, because the solid is dissolving. And eventually it will be nothing left. So this one grows, that one shrinks. In this case, this one dissolves and this one grows. Now, one question they can do, and they do ask, is how do we purify copper ore, or normally aluminium ore, or some type of ore? You attach your ore, your impure like copper, to an electrode. And you have a pure copper electrode there. You apply a current, the ore dissolves, all the junk falls to a little pile on the bottom here, and copper keeps putting onto this electrode, and so you go from impure copper to pure copper. And a pile of slag at the bottom. Make sense? So they use electrolysis to purify stuff. And here they use this to create a voltage. This would be the negative volt, this would be the positive. And what is this thing here called? What's this called? It's a piece of plastic tubing. What is it called? A salt bridge. Somewhere there's a salt bridge in the, I remember where it is in the back room.
Also the one we made.
Yeah.
One cell stuff.
Okay, let me tell you something. That basically summarizes it.
So we tried with everything.
There's two things that you last of all need to know, and then you know everything about this.
I'm just saying, bro. Nobody like you.
Thanks a lot, Kyle. What do we got here?
Everything.
Kyle, everything. You're number 7.
So, I'm telling you, let's take a look. Oh, to define what this is.
That's fine, I'll staple it. Thank you very much.
Just leave it here, so.
Thank you. Okay, we've got a way of summarizing this whole reaction, or cell. A shorthand. This is how it's written. We take the thing that's oxidized, in this case, zinc. Now listen carefully. Zinc goes to form zinc 2 plus. So we write what starts first? The zinc. Then it becomes zinc 2 plus. Because it changes phase, we put an arrow, a slash. Because there's a salt bridge next, we do this. 2 slashes, that's the salt bridge. Then something's got to be reduced. What was reduced? Not copper so much as copper, 2 plus. And it went to form copper. And that is how we summarize the reaction. All happy? Now I'm looking for the data sheet. Oh, please guys. Aiden, thank you. I'm looking for the data sheet for paper 2. There's a formula for working out the voltage of the cell. Do you guys remember how we worked out the voltage of the cell? We took the top reaction, half reaction,
Oh, yes.
and we reversed it. We reversed it. Did we do that?
Yeah.
I'm just looking for paper to, I can't remember the exact formula, but it's this. It says something like this, E theta, or something like that, equals E reduct minus E ox. If anyone has got a textbook or something that they could look it up, the paper 2 data sheet has got a formula like this. It's got the E theta of the cell equals the E theta reduction minus the E theta oxidation. And you'll find it, and anyway I'll revise it. But I can't remember the exact formula. Now this is what you do. Do you remember we said we take the first reaction, half reaction, the one near the top. That is the oxidation reaction. We reverse it. That means we make it minus. So here's your second, this is your top reaction is minus. Your bottom reaction is plus. We haven't changed it to a negative. So here's the voltage of the lower reaction minus the voltage of the top reaction. equals the voltage of the complete cell. Make sense? Thanks, Pascal. Everything? Great stuff. Okay, you're number 8. Okay, so find the zinc half reaction on your redox table. So it was minus 0.76. Find the copper half reaction on your cell. Remember, that was the one copper, metal, and copper 2 plus. That was 0.34. So what is 0.34 minus 0.76? And remember, it came to 1.1 volts. 4 plus 6 is 10, 7, 8 like 10, carry 1. 6 and 40. 1.1 volts. Do you see the formula that we use? So it's the same as taking the top one, reversing it, adding the bottom one. Now guys, what is wrong with saying you take the top one? Why don't we ever say that in the exam? Why don't we say we take the top half reaction and reverse it?
So could you please confuse the tables?
Because they don't know which table you're using.
Because it's one table.
Closest to lithium, reverse it, add it to the half reaction closest to fluorine. Because there's 2 different tables. And then you guys are going to do questions on this topic. Now let me tell you something. It is only the beginning of July. I have never seen a group of matrics more prepared than you. I have never seen it. Secondly, I've never seen a group of matrics with a better attitude than you. I mean it. That's not a lie. With a 2 in place, if you don't all get 80% by the time we've worked through all those booklets, there's going to be something wrong with us. I mean that seriously. So for the remaining part of the year, we're going to work through past papers. Starting, please, Friday, bring those paper 1. We're going to start with the paper 2 booklet. That one that the department gave us. The one that looks like this. Okay, great. So we're going to be working through these. We'll start with paper 2. Bring your text because I also want to show you which pages you must put a line next to what's important. So bring your paper 2 and bring your textbook on Friday. Now, are there any questions before I go? I want to revise acids and bases quickly. Okay, acids and bases. But I just want to see if there are any questions left. Okay, so let's do acids and bases.